Hmm. Twitch is streaming now, just YouTube. Yeah, YouTube streaming. Testing, testing, 1, 2, 3. Hmm. Yeah, seems to be working. Okay, so today we'll be continuing our work on the previous game. We're almost done with that game. We have to just do the check answer functionality. So we'll be moving on to that. Let's move this here. I wonder if they'll ever have any plans to upgrade it to be like a web situation, like one of these. Hmm. I wonder, can you dock it? You can. Interesting. Yeah. Now let's go back. Let's create another one. And we'll keep this in the code area. Make it smaller. Keep it here. I don't really use this area that much. Get to the screen. Yeah, cool. Oh no, I have to set it to always on top. Always on top. Always on top. Let's open up the game. Uh, yeah, today I've decided that while things are loading up or whatever, we shall watch the second part of the GD's of the Godot tutorial from Braki, the one about the coding language. Godot script tutorial. Last time we did this, which was very nice, much nice experience, and this time we'll be doing this. Okay, let's update arc first. I'm very curious about the Zen thing, the Zen one, Zen browser. Uh, I'm not downloading it as of right now, just because I want to see uh, how the implementation of Firefox's vertical tabs and all will come out.
Have to understand everything the first time.
Let's just check it out though. Control. Let's see logic options. There we go. Oh, how do you delete stuff from this? Programs. Let's see. Local. I also have Keurig apps. Let's see. Can I not find the icon? Open file location. That one. Should be somewhere. Uh, where does it link to? Maybe that's why it's not working. Hmm. Let's see. First, let's put this on the screen. Yeah. Now let's search for arc exe location. Okay, Windows app, the browser company. Okay, oh wow, almost full. Have to clear things out eventually. For now, let's go to what's it? C programming files. Windows apps. Let's see. Did it change recently or something? Window apps here. Continue. And properties, read only, security, advanced. Hmm. Yes, access control is script. Delete it and create a new one. Hmm. Let's see. Unable to open Windows app folder. advanced, click on the change line. By simply renaming the Windows apps folder. Yeah. Free security advanced. Property security advanced. Exchange. So then select user group and go to enter the object name field and add your username. And so let's see, is it the Lenovo one? Users Lenovo. And let's continue. And Lenovo. Yeah. Here go to the owner section again. Check the box next to replace owner and subcontainer in object as supply. Yeah. You'll see the owner name has changed to what you just added. The add button will also get highlighted. This allows you to add permission. Next on the permission entry for Windows app, select principal. Close and reopen before you can view. Yeah. So we are here. And add button also, this will allows you to add permissions entry. Allow restricted. Yes. Select a principal for Windows app. Fun and fonts. Fine now. Select the username we added. Okay. Control. Okay. Fly. Okay. Hmm. Okay. Glad this seems to work for most. Hmm. Let it finish doing whatever. I should add like a thing to show you that the browsing company. Okay. See, Windows app. Okay, finally. Browser. Arc. Okay, this is like specific to the version. So, which is not what I want. Oh, create desktop shortcut. Hmm, let's see. Then file location. Let's create a browser desktop shortcut. Yeah. Go to the start menu, all apps, drag snap from the vertical list to the display. It worked. Yeah. That did not work. Hmm. It used to work fine. So, see. On Windows. Maybe it's a Mac thing. Hmm. Click on the start menu, click on all apps. All apps. Okay, this worked. Hmm. It works. Let's see if I can add just that. Uh, Desktop. Put it in this. Let's go. Let's master this. Uh, do, do, do. Just added it. Oh, where is it? Arc. What? Why does it not show up? That's so strange. Hmm. Now let's see properties. General. Link. What is this link? Details. Okay. Hmm. I don't know what's happening. Okay, we'll leave it for now. Doesn't seem to work. Okay, let's go back. Yeah, this has loaded up. I have to update the submit answer thing. Check answer. Uh, Debug dot log answer correct. Let's add the debugger. Put it in this corner. Yeah. Yeah, let's see. Watch this. To watch. To watch. Should in theory all be the same. So So if they don't match, it's wrong and you return. If it's correct, then you go here. Then you win. So 1, 2, 3, and 4. Set this up to 4. One here, here. Unable to pass text. Make it correct. Okay, this was working. Let's try then. What? Okay, the only thing I have to update is the wrong vector up. Star. Let's go with 3. See what. See. Yeah. Oh, 0.75. 0.5. Yeah. So 0.75. Yeah. Let's delete this. Let's save. And Hmm. Hmm. Let's see. Hmm. Let's see. What are the counters? Z positions. Caution counter. All of them should be at 0. 0. Da, 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 da. Vector to hmm. Score manager. Yeah. Do virtual dot delete call that much RAM. Yeah. One. And 6. Third set delay. Let's make it a sequence. Sequence main sequence dot append interval calculate 0.5f. Let's see. Convert all of this to a tween sequence. I'll make them separate lines. The tween sequence is called main sequence. Okay, insert. Okay, nice. Yeah. Load up. Let's go. I don't need this part of it. There's no zoom in or anything, so wait, but I can do all of this here. P then prevent. And copy paste this. Yeah. Not even. Yeah, let's give it a try. I've been reading a new series called The Necromancer Academy. It's been pretty fun so far. Or is it doing it twice? Uh, Too fast. Hmm. Okay, let's try it now. Yeah, one, two. Okay, I think the game is done. Oh. Hmm. Um, let's see. Hmm. Control D, Unity, delete, asset, store, downloaded, asset. Yeah. Let's see. Windows XP. Downloaded asset bundles. Asset package from cache. Go to the asset package cache. Okay, let's see. Package manager, folder, package manager, folder icon. Let's see. Select the icon besides. In the preferences window. Yeah, wait. Edit preferences. Package manager. See. My assets. Explorer. Sort by size. Oh, folder name group. Go by name. No. Yeah. Let's see. This open. This open. Let's see how big this is. Properties 3 gigs. Yeah, not that bad. What is taking so much space then? Is that all the videos? Let's see. Let's open up the videos. Oh, videos. A lot of these are no longer required. How's the recycle bin? Let's do an empty. Clear it all out. Okay, quite a bit in there. Oh wow. 35, 36, 37, 40, 45, 50, 50, 60, 65, 70. Yeah, it's like 77 gigs in my recycle bin. That's crazy. But I was doing a lot of stuff, so yeah. Let it all get deleted. Uh, yeah, okay, at least I know the source of it. Let's bring OBS here to record it and send it in. I thought the assets would be the issue. Oh. It's kind of mesmerizing to see so much get deleted. Cycle that. Okay, let's got this. 3, 2, 1. If you enter the wrong number, yeah, let's do. This is an always on top thing. I use it. Hmm. Window Control T. Window Control T. Okay. Let's open up this videos folder. What is the gameplay? So the balancing vision game. Let me know if there should be any changes. Why I keep cropping it out? Why does it keep sending that part? Whatever. 30 gigs left to be deleted. Let's see. Task manager. Taskbar settings. Task queue, Copilot widgets. Okay, something is under control T. This was the issue. Calcium oxide product. Equation given in the textbook. What's in the textbook? Balance chemical equations, zinc, sulfur, also iron, iron plus water. Gives you rust. Hmm. Okay, and water, rust, hydrogen. I have all those paths. Then zinc, zinc sulfide. Let's do the iron and water one. Is it done? Now, how much space do I have? Yeah, I have around 100 now. Much better. Add some rust elements. So let's see. Ion. Free. Mm. Sounds. Low poly weapons. Okay, looks good. Hmm. Okay, let's go with this. Assets accept. This can go over here. Download. So let's do Rust. The balanced kitchen. And rusted materials. That's how rusted is rusted. Yeah. Import. Import. Download. Import. Good thing my code's barely reusable. Okay, see, and let's get rid of all these gizmos. Showland rotations, prefabs, rusted. Yeah. Rendering, render pipeline converter. Uh, Okay. I have to change this to be 3. See, ion. Then water. Rust. Control C, Control V. Hydrogen. It's on 5. Okay. Five. Control C, Control V. Control V. Hmm. And 75. Let's see. Eighty-five. 100. Okay, 160. $100. Calcium. This will have to be Fe ion. Hmm. Let's see. This will be. Uh, let's move the lines up a bit. Minus 45. 43. Minus 70. Not one, not two. These two can go up together. Minus 75. Mm, minus 60. And this up. 7, yeah. See, this one has to be we'll make this hydrogen. Hydrogen. Control C, Control V. Three. And this one will be oxygen. Oxygen. Oh, am I missing anything? So, yeah, just one extra element. Oh, oh my god. Hmm. -90. Yeah, this line can go. Let's shrink the table. Let's move the table up. Move this stuff down. Table up. Height. One. 5. Yeah. And let's make this 120 minus 50. Minus 77.5. Yeah. And let's see, calcium. This will be hydrogen. Hydrogen. This will be ion. Then Control C, Control V. Oxygen. What's 92.5? Okay. Now let's copy paste this. Control V. That's just oh, hmm. Can I increase the amount of rust? I'll probably go with something else. I'll just take a quick break. I'll be back. Okay, I'm back. Took a bit of a break. What happened? Okay, let's continue with our game. Refresh Twitch. Yeah. Let's see. We're done with that. Then so add counter, water counter, just shit. Yeah, this one can go. Models. Battery. Weapon. Prefab. And weapons. Yeah. Old weapon. Yeah, I can use the rusted thing from here. I'll use like a rusted axe. Let me just open it up. Let's see it more clearly. Yep. That's what we'll be going with. Prefabs. Not prefabs. Models. Fly. Compression. Fly. Compression. Fly. Compression. Oh, sleepy. Yeah. Richness. Changed. Add these tables for now. Yeah. Back down here. So we have puzzle game props, prefabs. These are also carbon dioxide. These are plants. And free toolkit, assets, prefabs. Okay, this demo thing can be deleted. Okay, assets, prefabs. On this, Hydrogen. Yeah. Oxygen 1.6, hydrogen 1.6. And water pistol to 1.6 as well. Water pistol. Materials. Hydrogen. This can be used. And this can be. Good thing I made that hydrogen acid earlier. The hydrogen water, if we yeah. Water, and this can go the black weapons, iron weapons. Oof. 0.6. That's too big. Use a dagger. These hiccups are insane. Now let's get the hydrogen. You. Calcium plus a bladed weapon, a rusted weapon. Quiver, hammer, axe. Let's do an axe. 1.6, 60, 60. And 5. Let's see. Okay. So LHS. No, both of these guys. Plus 100 minus 100 minus 100. 50. Looks centered-ish. Two hundred. Hmm. I'm very hungry right now. See, let's download the updates. It kind of just blends in. Let me see if I can make it darker. Hmm. Whatever. I make it shorter. Let's use a normal axe instead. copy. Oh my gosh. Copy component is component values. Max 1.25. Yeah, I'll go with that. Shrunk its height a bit. I'll see Control V. Control C, Control V. Dagger. Dagger, dagger, dagger. Oh, hydrogen. Hydrogen target. Oxygen. Rust target. Rust. Water. Dagger. Oh yeah. I'll be back real quick. Okay, back. all the objects are just different. Uh, Copy component. Move component, remove component, and move component, remove component. This component is new. Copy component. This component is new. Copy component. This component is new. Open up the gizmos. Water pestle. Pump. Is it? Move component, add box colliders. Yeah, much better. Bring it. Yeah. Yeah. Ah, the chapter's glitched out. Hmm. Hmm. Okay, let's see. I'll just see if it works for now. What happened? Yeah, all-in-one manager, RHS table goes there. Then let's see, ion name, ion, that's a hydrogen. Okay, ion Fe, 0.1. Name water H2O. See, just name just uh, let's make all the names for this. And roboto bold. Okay. Iron water dust. Let's remove the space. Okay, dust Fe sub 3 A slash sub O sub O. Okay, just go this way and go ion okay, hydrogen 2 hydrogen. Nice. Hmm. What is happening with this one series? It's been like on sort of hiatus. Mm, okay, let's see. On target, 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 target. Okay, I'll just hit save for now. Pandemic. Did I increase it? Oh, that's a. Okay. Hmm. Yeah, not all worked out properly. I have to change that and all. Okay, I shall go for lunch now. So yeah, see you all after that. Let's continue where we left off. Okay, let's go back here. On water. Yeah, let's start with setting up the counters correctly. Ion target goes to ion counter. Then we leave those there for now. Then Water goes to enablers. Water goes to water counter. Then rest is the rest counter. Hydrogen is the hydrogen counter. Okay. Block. Delete. Yeah. Well, I'm curious. How many people, how many bots have been blocked so far? That one's over. I'll do Control T Twitch.tv. Okay, I will go to create a dashboard. Why does it keep showing me that? Today is what? Tuesday. Yeah, tomorrow should be back at 9. 8, 9 to 5. Edit 9 to 5. Save. Okay, let's see. Analytics, no. Community settings, moderation. Let's see. Oh wow, that's a lot of terms that got blocked. Was not expecting that. Okay, let's go back here. Hmm. Hmm. Okay, the counters have been updated. Hmm. Okay, let's update the targets. So iron as the iron target, then water has the water target, then rust as the rust target, and hydrogen have the hydrogen target. Okay, okay, that's all set up. Now LHS stuff. Okay, let's see. Ion counter, ion multiplier text on LHS. Okay, hydrogen water. Plus the oxygen multiplier. And this has the multiplier of 1. Okay. Now rust will have the right hand elements. Okay, rest will be iron and oxygen. Iron and dust. Iron and oxygen. Hydrogen counter will be hydrogen with a multiplier of 2, and this can hydrogen 2. Let's see what was the, let's go back, close this, close this, close this, unity, close this. Yeah, let's go here. Fe3O4. Okay, so rust is Fe3 and O4. So 3 ion, let's just test it out for now and check submit button. Okay, let's do 3 and hydrogen oxygen, then 3 ion, hydrogen, oxygen. Okay, let's see if it works. That should in theory all work out if my code was correct. Okay, wait, I have to put my headphones on. Is there a thing to like view the volume? Can this be pop it out? Okay, let's just try it out. Control S, save everything. Everything will be in one spot. I have to adjust that, but that can be done later. Okay, that's working. Okay, so this will be 1, this will be 3, this will be 2, and this will be 2. Right. Fe3 or 4. You have to increase that max limit as well. Let's see what the answers. Equals 4H2O. No. Yeah, it requires a 4. Okay, let's increase the max. I'll make it up to 10. I'll just go with that. UI follow. Let's see. Private private ah private constant and max uh max count equals 9. Okay, max hmm okay as equals max count. Yeah, should work now. Let's try it. And also let's set this to correct proportion. Hmm. It should be done. Now let's click. Everything is over there. There's some delay with the activation too. Whatever. 3. You have to somehow get those behind it. Get these in front. Okay. I can figure that out later. Let's see. This remains 1. 3 H2 so that the oxygen matches. 4. Okay, nice. Now I just have to correct the delay and the activation. Let's see. UI follow. Hmm. UI follow. Where's the thing that activates it? Not here. Let's see the P script. Counter.set active. Oh, yeah. So this wanted to happen after. Do virtual delete calls 0.1 F counter. Okay, this. Copy. Yeah. Okay, that should work now. Also, I just changed the wrong thing. New vector, new vector 3 point 0 comma 0.75f comma 2f. Okay, I should sort it out. Hmm. Okay. Hmm. Okay. Do I need the delay? Kind of doesn't like feel right. Let's do 0 counter. Okay, let's see how this works. Hmm. Hmm. Okay, let's hit play. Let's see what happens. Let's restart it. Yeah, this is much better. Where is that? Yeah, I guess those are like UI elements, so that's ah. Guess I'll spawn it higher. Spawn it here. It should be fine. Let's change it to spawn. Let's just do mock spawn. UI context 1. No, keep it at 1. Hmm. Let's do 1. Yeah. Let's see how it goes. Hmm. Okay, let's play the game. Everything should be fine. Only thing left would be to correct the positions. Where did I give that? Are the initial answers correct? Let's see. This can go. Hmm. Okay, this can be a separate function. Uh, factor stack method alt n see date text update text. Okay, and let's do an update text here. Update text. Yeah. Okay. Let's see. That should all work out now. Okay, those are global variables, everything, atom, yeah, it's all global. Should be fine. Okay, let's try it out. That's why I was getting that glitch earlier. That explains it. Let's test it out. Okay, let's see. Yeah, this shows the actual values, so can start with iron, match that up, and then you need to match the oxygen. And you have to match this up. Yeah. Okay, let's do a restart just to see it all works initially. Okay, it's no longer given. Three. Oh. Okay. Gameplay is all done. This one like camouflages a lot. Wonder if I can change the color of the wall. Material. Let's see. That kind of looks nice. Not that good. A dark red. Ooh. This kind of looks nice. Let's see. That's too bright. A dark red. 70. Okay, let's see any other colors. No. Looks nice, but like blends in with this. Let's see. No. Let's stick with red only. Okay, cool. Or orangey hue. But here, like pinkish. No, let's do red. Okay, nice. That was very successful. Okay, cool. Uh, Now to find the actual positions for the props. Yeah, these two can go. Let's hide these. LHS, RHS table, school manager. Okay, let's set active to false. LHS set active false. RHS table set active false. Okay, so this man append callback. LHS table dot set active true. Main sequence dot append callback RHS set true. So join. It should all work. Hmm. Hmm. The tables, yeah. Okay. Clear. Yeah. Now I can just focus on their locations. Um, the water one will normally keep over here somewhere. Let's get rid of the gizmos. Let's see. Copy. Paste. Okay, water's done. Iron. Should I hang it up? I'll hang it up here. Hydrogen can go like in this or something. Okay. Iron. The 1.2. 2.5. Oh, 2.8. 3.2. Okay, copy. Two and paste. Yeah, this axe. Where should it go? The axe you can like keep underneath. I think that'll be fine. This. No, this will go there. Axe you can keep under here. So do this. Copy, paste. Hmm. What I can do is like keep it here. Get up. Copy. Okay. Copy. Control C. C. Paste. And calculator. 2 divided by 1.5. 1.5. 1.333. Let's go here. Okay, it's all done. Let's record the gameplay. OBS. Bring this there. Got let's record. Okay. Okay. Anderson. Updated the chance formula to a Rust equation from the textbook. Let me know if there should be any changes. Okay, so done for now with this. Save, very important. Let's get to this. I haven't. I'm supposed to check it out.
You have to understand everything the first time. Also, it's totally okay to stop the video and try some of these things out. You can always come back to it at a later time. We've made sure to split everything into clearly named sections, so hopefully you'll be able to use this as a reference manual going forward. And if you're a seasoned programmer transitioning to GDScript, this video should provide you with a nice overview of the tools at your disposal and how to approach doing different things. Keep in mind that this is a video on GDScript, not an introduction to Godot. So if you've never opened up Godot before, I suggest you begin with our video on making your very first game in Godot. Alright, without further ado, let's learn GDScript. But first, hello world. So here we are in an empty Godot project. It's really spacious in here. As it is custom, let's begin by making a script and adding some code to print a message. To do that, we need a test scene, so let's go and hit the plus. I'll add in a node, rename it to main, and let's save this as a scene, so I'll hit Ctrl S, hit save. Let's add a script by pressing the scroll. We'll use the default template, and the name of the script should be main as well with a non-capital M. This creates a script with two functions. We'll start by focusing on the top one named ready. Think of this as the start of our game. As it says here, this function is called when the node enters the scene tree for the first time, which happens right when we play our game. So we can put code in here that we want to happen immediately. I'll get rid of the other function for now. You can zoom in by holding down Control while scrolling. Now right now, the only thing in our ready function is the pass keyword. Pass basically means do nothing, and it will appear in functions we haven't filled out yet. So let's replace it with some code that prints our message. We'll write print, and inside the parentheses, we'll put our message in quotation marks, hello world. We can then run the game by pressing this button here or hitting F5. It's going to ask us which scene we're going to run. We'll hit select current. And while our game isn't very exciting yet, we can now see that the console prints our message. The output window here, or the console, is where it will display prints, and it's also where we check for errors. Now to stop our game from running, we press the stop button here or press F8. Syntax. Now, this might have worked for you and it might not. That's because there are a few things to be aware of when writing GDScript. The first is that statements like print here terminate with a new line. There's no need to add a semicolon at the end like in many C-based languages. And GDScript, similar to a language like Python, uses indentation to determine the structure of your code. This means that you use tabs to tell GDScript where your code belongs. In our example here, I'm using a tab to tell Godot that our print line belongs to the ready function. If I delete this tab, I get an error. Also, GDScript is case sensitive. So if I write print with a capital P, I will also get an error. So just a couple of things to look out for there. Now, printing to the console is cool. Or I mean, maybe not as cool as backflips, but well, I can't teach you to do those. But I can teach you how to display text in the game window instead. To do that, we'll need to modify a node through script. Modifying nodes 1.0. First, we need a node to modify. Let's use a label. So I'll add a new node, choose label. I'll zoom in, center it on the screen. Make some more room. Let's add a default text. This is a label.
Okay, there's some overlap with the hydrogen. Let's see, hydrogen target. Let's make it 12. Let's do it for all of them. To 12. Yeah. Hmm. Hmm. Yeah, I'll have it create a text field and then go here. So, the stream view, and let's see if the positioning is fixed. No. What? Minus 20, 15. Let's try that. See how it goes. Ten, 14. Yeah. What I just adjusted manually for each of them. Can be 10. Yeah. Doesn't all need to be equal. 10. Then 12. Yeah. Ten, 10, 10. See, hydrogen's a much bigger world. Hmm. So yeah, that's a bit too close. This is fan. That's somehow too far. So target protein. Counter. Hmm. Okay, let's see. We'll make it 12 plus 12, 9, like that's 12. Hmm. Yeah, this can be a bit more honestly. Gym target. Let's see. Water. That's a bit too much. Think I'd go with like 11.5. Let dagger. The dagger is correct. Okay. So hydrogen 16. This will make it like 11 and 11. Let's see how it looks. Okay. Could just be 15. This. Hmm. 15. This can go back a bit. This is fine. Not fine. So adjust one like 10 and 5 and then go to 15. Okay, see, okay, okay, okay. That's all sorted. Now the help button. Okay, and okay, let's see, and do vector 0. Let's not delete it now. Hmm. Okay. What is the health button? Help button's current size. That's one. 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 Simplify. Message restarts if it gets hit. Actually, if score manager dot instance dot get score less than score manager total score minus 1 and do that. Else if score manager equals this. Else pop up let's see, public game object int text. Hmm. Okay, let's see. Let's add a text object somewhere. UI text and text. Okay, and text. Hmm. Okay, let's place it down here. As a whole like space. So let's see. Hmm. Sure. See. Let's see. Clear number of elements on the left hand chess and RHS equal short equal 'Kay, if I make it green, how does it look? One 20, yeah. The see word spacing, the font style, spacing, characters. -4, 5, 6, 7, 8. 105. Full button. Let's just table sequence main So dot win you main dot append callback C is activated true. Okay, if that happens, main sequence join append um, mm, uh, and text dot transform dot to scale and sequence dot append interval to let's make it 4 4 seconds, then transform reduce scale 1 the out expo when you're coming out you want to see it logo. Zooming and expo, and I just stick with that. So then and dot transform dot 0 and main sequence dot and callback is activated false. Can probably loop it back, but yeah. Let's see what extensions are. Restart it. Disconnect. Start. Let's see, can this be condensed? Can this be condensed? No. Can it be condensed using a yo-yo loop? Hmm. Let's give this for now. Font change. I love. Yeah. A button. Okay. LHS. RHS. Hmm. What color is such was yeah. Let's see, what is the original color? Structure. Okay, I want to change the background color a bit with the fan, so got some review from a student. So curious what it would be. Start. Also, where I have this twice. This is that becomes 1, this becomes 0, this part, just set it hint, text, transform, that looks vector 0. Okay. Okay, let's test it out now. Should all be fine. Why is it not working? All button. Yeah, score. Let's put the debugger on. Then rest can be closed. Cancel. Yeah. Score less than this. Score equal to this. Should all be fine. Is activated true. Is activated. Watch. Yeah. To watch. Yeah. Okay. The given. No. Hmm. Okay, score is less than that. Okay, continue. Does it have to be during a week for this to function properly? Let's see. A week. Is it saving it to 0 because it happens later on? And might be what it is. Let's see. If I change it to a week, what happens? Okay, continue. Okay, yeah, that was the issue. Okay, bring all of this here. Show hand is activated. I have to have an in for false. Mm-hmm. Okay, on complete. On complete. Let's see, is activated equals false. Okay, now let's go back and try it again. Okay. Let's go here. Okay. It's detecting it correctly. Okay, it's working correctly. I hit it again. Okay, nice. Mode. Go measure. Health. F equals. Hmm. Okay. Yeah. Okay. 4, 3, 1, 4. Finished implementing the hint. Functionality. Let me know what color you'll decide on. I'll send the gameplay vid after that. Okay, yeah. Let's go back to this.
I'll center it and override the font size. Now, to edit the text of this label through script, we need two things. We need a reference to the label, and we need to access the property in the label that we want to change. In this case, the text. If we hover over text, we can see the name of the property through script, which is text with a non-capital T. So in our main script, we'll first get a reference, and we can actually do this by simply taking the label and dragging it into our ready function. Then we can access the property by going dot, and we'll type in text and set it equal to hello world. And now when we play, our label changes to hello world. And we can use this exact method to change other things as well, such as the color of the text. In fact, there's a property called modulate, which allows us to tint sprites and UI elements. In the inspector, you can find it all the way down here under visibility. Let's change it to green. So again, we'll click and drag to create a reference to the label, right dot modulate, and set it equal to color dot. Here we have a bunch of different colors. We'll choose green. And voila, our label is now green. So this is how we can make changes to nodes when our game is running. But right now, not much is happening during our game. So let's see how we can use input to make our game respond to our actions. Input. Let's say we want to turn this label red when we press the spacebar. To do this, we first need to set up an input action. We'll go project, project settings, input map. Here we can add actions. Actions allow us to bind keys to something that we want to happen. Common actions would be shoot, jump, or so on. In our case, we wanted to change a color. I'll just go ahead and call it my action, so we can use it later for other things. Now let's hit add, and here's our action. Let's bind a key to it by pressing plus. It's now listening for input. I'm going to press the spacebar and hit OK. And now our spacebar is bound to my action. Then in our script, we need to create an input function. We'll write func for function underscore input. Let's hit enter to autocomplete. Now, just like ready, this is one of the built-in functions of Godot. But instead of being called at the start of the game, it runs every time the game receives any input, such as when we press a button. Event is what we call the information about what triggered the function. Was it a movement of the mouse or the press of a key? We need to check it The event that triggered the input was our action being pressed. So we'll write if event.isAction.
I shall close the window. It is getting hot right now.
Been pressed. And as you can see, our action shows up here, my action. Then we'll put in a colon, and if we pressed my action, well, then we'll change the color. So we'll drag in the label, write dot modulate, and set it equal to color.red. And we can just as easily check if the action was released. We'll go if event.isAction released this time, my action. Well, then we'll take the exact same line and change it back to green. So now when we play and I press the spacebar, it turns red, and when I release it, it turns back to green. That's right, we made a party. A disco party. Now this is just one out of many ways to handle input in Godot, but since we're focusing on the GDScript language, I'm not going to go further into it here. I'll make sure to provide a link to where you can learn more about input if you're interested. Variables 1.0. Variables are essentially containers that hold information. In the case of a player character, we could use variables for information like the player's name, health, damage, and perhaps if the player is alive or not. Let's make a health variable. At the top here, I'll write var for variable, the name of our variable, and then we'll set it equal to a default value. Now we can print this variable inside of our ready function. We'll write print health. And if we play, you can see that it now prints 100. Now we can easily change our variable. So before printing, let's assign a new number. Health equals 40. We can also assign a calculation. So health equals 20 plus 30 minus equals 120. Let's look at an example where our player takes some damage and we want to press, and then we'll subtract from our health. But as you can see, we can currently reduce our health below 0, and nothing happens when we do so. If we were making a game, we'd probably want our player to die and the game to restart. Luckily, we can make our game react to variables by using if statements. If statements together. We've actually already used if statements to check if our action was pressed, but they can do so much more. Yet they are really simple. An if statement is just a condition that needs to be met in order for the code inside to be run. Let's add an if statement here.
Oh wow, this mushroom's kind of all over the place. Call down, signal up. Let's play a game of chess. We haven't done that in a while. So here choose just save everything and we're back. Piece, take that. Yeah, that's more important right now. Let's prevent it from doing that. Take it, captures the captured back. Yeah, move the pawn, protect everything. Let's go here. I think I'll castle this side. That was a free piece. Mistake. Oh no. Let's see if I get the queen. Yes, I do. Nice. Okay. Came out on top of that. Luckily, that was not an intentional oh no my queen moment. Hmm. Hmm. Take that. Hmm. Let's attack that. We'll get rid of this. Hmm. For you. Hmm. Push this. See what happens. Okay. Can't capture that. Okay. Checkmate. So I have to move that pawn forward and give it an escape route. But yeah, this was not my best game. Let's see.
We have to check if our health reaches 0. So I'll make some room, write if health is less than or equal to 0. Add more conditions to one if statement is true. We can also choose what happens. elif for short. So we check if our health reaches we're injured, and at 0, we die. Very cool. Note that the if statement we made here is nested under another if statement. You can easily layer if statements to get more and more specific functionality. However, try not to overdo it. You can quickly get lost in the ifs. Actually, a lot of people don't know this, but that's why programmers and philosophers have so much in common. We both tend to spend a lot of time with the ifs and the what ifs. So if you get the what, a line. So if we have some code, we can make a comment above the line, and this is a comment about the code that follows, or we can make one right after. And this is a comment about this line only. We can also use comments to temporarily remove parts of our code from being executed. Here we simply put a hashtag in front of the code. And it's good practice to omit the space here to indicate that what follows is code. We can also select multiple lines of code, right-click, and toggle comment. Just remember that you can't have a completely empty function. We need to add the pass keyword to avoid an error. Variables 2.0. When creating or declaring a variable inside of an if statement, for example, we can only use that variable inside of the if statement. This is called scope, and it's something that beginners often make mistakes with. If we want to use a variable in many different places in our script, we make sure to put it at the top, outside of any functions. To true, and this runs completely fine. That being said, we still need to be aware of what type of data of the parentheses, and if we print this, it works fine. We can do a similar thing to say convert a float into an integer. So if we have a variable called pi that is equal to 3.14, then we can convert this into an integer by going int pi, and let's print this, and it prints 3, a whole number. Note, however, that this automatically truncates the number. It does not round. It simply gets rid of the decimals. So 3.9 also results in 3. Some other data structures that are really common in GDScript are vector 2 and 3. Vector 2 stores 2 floats, x and y, and vector 3 stores 3 floats, x, y, and z. These are most commonly used for positions, so I can create a variable called position with some coordinates. I can then modify one of the components, so position.x plus equals 2 adds 2 to the x component, and then we can print the whole thing. And this gives a vector 3 of 5 minus 10, 5. Now, by default, GDScript is what we call dynamically typed. This means that we don't define what type of data a variable can hold when we and less performant than static typing. Luckily, GDScript allows us to statically type any variables we want. We can pick and choose totally based on preference. So here, if we have a damage variable, we can specify the type and then set the value. So now this variable will always stay an integer.
I just wish you could put int over here instead of having to put semicolons and then this. Like, it's so much extra work. Like in Unity, in C# at least, you can do var game object var text equals new game object. Current script code. So if I do it here, equals syntax. Yeah, so you have this way, or you can just set it as a game object, which I think is a better way instead of doing like var. You're already typing it, then you have to do game object, which is a bit extra, honestly. Like Mojo does this as well, which
We can even have Godot automatically determine the data type by simply writing colon equals and then the default value. This is called inferred typing, and the result is exactly the same. The type is still static. Godot simply recognizes that 15 is a whole number and sets the variable to a type of int. This also means that the variable cannot change to another type. If we try to set it to a string, we get an error. Now, adding export in front of a variable will allow us to set it using the inspector. The value that we set in the script will just be a default value. So if we save this and select our node, we can set a value in the inspector. If we print our damage, we can see that this updates in our game. And we can always press the circular arrow to revert back to the default. Now, sometimes you want to define a variable that cannot change. For this, we use constants. So I'll write const for constant. We'll call it gravity. As you can see, it's standard practice to name constants with capital letters. And we'll set it equal to negative 9.81. Now we can use this like any other variable, but we cannot change it. If we try to do that, it throws an error. And that's it for variables. Great job. Those built-in functions like ready and activate things like jump, die, shoot, and was pressed, then we call our jump function by writing jump followed by open and close parentheses. And now when I press space, it displays jump. And at this point, in a variable, set it equal to add, and we'll add together 3 and 5. And it's a random number between 0 and 1. It's great for assigning probabilities to your code. Say we're deciding what loot to give the player, and we want to make some loot more rare than other. Well, in this case, we could create a roll variable and set it equal to randf. Then we could check if the roll is less than or equal to 0.8, which means there's an 80% chance that we print you found a common item. And if not, well, then there's a 20% chance that you found a rare item. And if we play this, most of the time it's going to display that we found a common item. But if we keep playing, eventually, there's a 20% chance, so at some point, we'll eventually find a rare item. That was crazy. We also use randf range and randi range to get a random float or integer between a minimum and maximum value. Say to assign.
Wish Unity just had it properly randomized. Like, if you don't set up the randomization properly, the like seed doesn't change, so it has the same randomness throughout. So let's see, is that mixer script here? Yeah. So unless you do this random init state, this piece of code, it will just suppose you have a randomness of like uh, 0 point of 0.5, like you have to print out a number, a random number. Without this code, every time you start the game, it will print out the same number. It won't be random. But if you do it with this, then it like properly resets the seed each time. So yeah, it's strange that I had to do this for it to be randomized properly, but yeah. Anyways, let's see.
Assign a random height to a character. So var character height equals rand I range for a random integer between 140 and it's due to 10. And we'll print that your character is, then we'll insert the height, remember to convert to a string, centimeters tall. And we'll roll a character, and apparently I am a giant. Basketball, here I come. Documentation. GScript is actually pretty well documented. And one of the really cool things about it is that the documentation is
Yeah.
linked with the editor. If you hold down Control and click on something we would like to know more about, such as the rand I range function, it opens up the documentation right here in the editor. This is a really quick and easy
Between, from, and to inclusive. Yeah, that makes sense. I know why they do exclusive for some of them. That's like, suppose you end on like 1, it won't count the 1. You'll have to do, it will just show up as 0. So in order to get 0 1, you'd have to use rand I range 0 2 in Unity. So, which is quite confusing. I don't know why they do it like that.
easy way to check if you're using a function correctly. It also works for classes, which we'll learn about later. Arrays. Sometimes you want a variable that can hold more than one thing. In fact, sometimes you might want to store a whole list of elements. For this, we use arrays. Defining an array is very easy. Let's make one to hold items in an inventory. So look, it's an empty array. When you add an element to an array, it is automatically assigned a number based on its position in the array. In this case, the first element, potion, has an index of 0, feather has an index of 1, and the stolen harp has an index of 2. So to access and print the first element in our array, we write print items, and then we access the first element, which has an index of 0. And this spells out So to remove at an index, we write remove at, and then the index 1, this removes the smelly sock. And to add a new element, we write dot append, and we'll append an overpowered sword to the end of the array. Now, arrays can quickly become long and difficult to manually go over. Luckily, we can use something called loops to help out. Loops. Loops allow us to repeat code run a certain amount of times. If we write for n in 8, it creates a for loop where the variable n starts at 0, then goes all the way to 7. So if we print n, we can see that it runs 8 times, and n starts at 0 and ends at 7. We say that n case, we will add a certain amount to our glass. We do a constant amount like this, or in real life, when I try to pour something in, the glass is now half full. And if we run this, we can see that the glass slowly becomes more full with a random amount each time, and then it's a random amount each time and not climb. Didn't, but we get a lot of overflow errors, and as you can see, our game is definitely not responding. Not good. Finally, in both for and while loops, we can use the break and continue keywords. Break. It's sometimes confusing to access each element the exact same way. Key value pairs. Let me explain. In real life, we use a dictionary to look up the definition of words in a language. The key in this instance is the word we're looking up, and the value is the definition. Dictionaries in GDScript work the exact same way. Creating dictionary is really easy. We write.
Let's optimize whatever we have in the scene. Yeah, might as well, you know. Let's do analyze textures. The plastic. Keep it here for now. Yeah. Plastic. Okay, yeah. uh, building floor. What even is using it? In ebony wood. That can just be black. None. Um, yeah. Get rid of these. Let's keep it simple. And yeah, that one's fine. Hmm. Plastic, yeah. Yeah, that's gone. This object share can go. Can't see any of this W. The yeah, all of that is deleted. This bookcase can go. I know why I had it there. Yeah, and let's see. See. Okay. Da. Keep that in case anyone has like weird proportions and stuff. Okay, that's all deleted. Don't tell me these have a texture player, but Uh, Chessboard, wood. Yeah. Yes, smoothness. Hmm. Okay. Get rid of a bunch of them. Okay, that's fine. Let's see. Control S. Any other strange optimizations? Okay. Instagram. I'll check that out later. Hmm. Hmm. Okay, onward. Um, get rid of it. Okay. What is the material for this? The height map doesn't matter. It's only for 40. Let's see, what about this thing? Dot loss. Okay. Okay, there's some green to it. Allow it. Allow it. Probably overkill, but still, I shall keep it. I think that's everything. Let's see the taggers and stuff. one. This could definitely be shrunk to 32. Okay. 40. Doesn't need that. There are no difference. Okay. Weapon scene, animation, materials, flow, enable GPU instancing, textures. This is 256, quality, fly, 15. Okay. I shrunk down the water. This is a shade of this. Shade of this says already been shrunk. Analyze textures again. Building flow tile. Thought I got rid of the PNG keyboard. Keyboard. Yeah, building flow tile. Drag and bug. Do this. Anything. Right. Oh, where is it? Fly. Don't need that. Fly. Let's see. Fly. Fly. Analyze audio clips. Everything's been compressed. Okay, all the textures are done. Okay, we're just waiting for the update for that.
Right bar. I'll call this one my dict and set it equal to some curly brackets. This is an empty dictionary. We can then add key value pairs inside the curly bracket value. So I'll create a you can split it up like this. And it's good practice to add a comment to the last entry so you're ready for a new one. And let's name this dictionary players. Then to get the level of a player, we simply type in the username. Let's print the level of our villain. So print, and we'll write players, type in villain, and this should print 35. And you can just as easily assign a new value or add another entry. So we can reassign the villain here to say 50 and add a new entry called Dwayne with a whopping level of 999. And just like with arrays, we can loop over a dictionary with a for loop. When we do this, we're actually looping over all the keys in our dictionary, so all the usernames. And for each username in players, we will go ahead and print out the username. I'll add a string to separate, and then the level. So here we access our players dictionary and input the username we're currently looking on to get the value. And remember to convert this into a string, so str to cast to a string. There you go, it prints our entire dictionary. Now, just like with arrays, you can have multiple data types of keys and values in the same dictionary. And even cooler, you can actually have arrays or dictionaries inside another dictionary. This might sound really abstract, but it's actually pretty cool and often comes in handy. Say, for example, we don't just want to store the level of each player with a value of 1, and another key called health with a value of 80. And at this point, it's a good idea to use tabs to keep our code clean. Let's duplicate this. I'll assign some values. And now we can access a value by using 2 keys. Let's print the such as player stats, inventory, buffs, and so on. And then in the curly brackets, I'll write ally, neutral. Check in our code if our unit has a certain alignment. Also, let's just give our enum a name here to say welcome. And now if we run, we can see that our console displays welcome because our unit alignment is currently ally. This is much safer than using, say, a string or an integer to represent states, because Godot will throw an error if we misspell a state. If, for example, I misspell enemy, we can see that Godot throws an error. But I think one of the real powers of enums is that we can use them for exported variables. To do this, we mark our variable here with export, and then set the type to alignment. And now we can actually set our unit alignment in the inspector. So I'm going to set mine to enemy here, and now when we play, it prints you are not welcome here. Really cool. Now what is actually happening behind the scenes here is that Godot is creating a constant for each state in our enum. So this code here is actually completely identical to our first line. And as you can see, the value here increases from 0 to 1 to 2, kind of like an index. So an enum is essentially just a bunch of constants with an increasing value, which means that with enums are match statements because they allow us to quickly add functionality from other languages. It allows us to execute different code depending on the value of a variable. In this case here, we can use a match statement to add some code for the different values of our enum. So I'll write match, then the variable we are matching based on, which is my alignment, colon, and now we add code for each value. So in case my alignment is alignment.ally, I'll print hello, friend. If it is neutral, I'll print a common piece.
Yeah, like
if it is enemy, taste my wrath. And a cool thing here is that we can actually add a default response as well. To do that, we do underscore colon. And so if it isn't any of the case, modify nodes 2.0. So far, when we need to access a node, node, it creates a path that goes into the player and finds the weapon. And we can actually store this reference in a variable. To do this, we simply drag it to the top and hold down Control while releasing. This automatically creates a variable with the name of the node and the correct path. And as you can see, it uses the onReady keyword. This is because Godot has a very strict order in which nodes are created. And if we open the game and try to find the weapon node before it exists, we will get an error. OnReady simply makes sure that Godot waits until all child nodes have been created so we don't get any issues. And just a quick note, the $sign here is actually just shorthand for using the getNode function. So this is actually identical. Also, you might have noticed that the path is relative. Our script is on the main node, so it starts right after that node. We can print the absolute path through script. We'll print weapon.getPath. This prints the absolute path starting from the root of our game all the way to weapon. Now paths are great for many things, but sometimes they can be a bit inflexible. They break if we read the child of the node we're working on. We'll talk more about parent-child relationships later. It is. We can even be specific about what type of node we want to be able to reference. That a certain event occurred. It's probably easiest to look at an example. Godot has many built-in signals. Take this UI button. If we select it and go to node, we can see a list of all the signals on this node. I'm going to connect the pressed signal to our main script. So double click it. I'm going to select main and hit connect. As you can see, this creates a function called onButtonPressed and over it prints money. Get it? Now this is because whenever we press the button, it emits the pressed signal and everything connected to systems can connect to. Then all we need to do is have the player emit the signal when we level up. Let's try it out. Instead of a button here, leveled up, and if we save this and select our main node, we can actually see that signal. We can connect it to other nodes, but just for this example, we'll connect it back to our main node. This creates an onLeveled function, which is called when the signal is emitted. Let's print a message that says ding. Now we simply have to emit the signal. Let's do that when we reach 20 XP. Here we'll write leveled up dot emit. Now when we reach 20 XP, it emits the signal, and we print ding. Awesome. We can also connect signals through code. I'll disconnect the signal in the editor, and instead in a ready function, I'll write levelup.connect and the name of the function we're connecting to, on leveled up. Careful here, this will probably autocomplete with parentheses. We don't need those, we just want the name of the function. And disconnecting is just as easy, disconnect. We can also pass parameters through signals. This could be used to pass the level we reached or other useful information. I'll just add a quick message that we can print. So on a signal, we'll add a parameter. We'll make sure that our function supports this as well. And instead of printing ding, we'll print whatever message was input. And then when we emit the signal, we can put in a message. Let's put in grats. And voila, it displays grats. And that is signals. Get, set, go. Or just get.
Okay, let me check out what message is sent. Taiwanese popcorn chicken recipe. Look at it later.
Get set. Getters and setters allow us to add code for when.
I don't think anything's happening for a while, so let's end stream here and we'll pick up tomorrow or maybe afterward if he gets back. But yeah, let's end this for today, and I'll see you all tomorrow. Oh, this has been off this whole time. Hmm. Oh, see you all